A function is just a mathematical rule that assigns numbers to points. The points might lie in a single dimension, or they might lie in multiple dimensions. For instance, when we have two goods like pants and shirts, a bundle of goods consists of two components, and so the bundles of pants and shirts are illustrated in a plane. A utility function then assigns a number to each point or each bundle in that plane. We'll illustrate it as here and show how it relates to the concept of an indifference curve. We'll call our two goods x1 and x2, and bundles of x1 and x2 therefore lie in a plane. We'll measure the utility or the happiness of each bundle along a third axis, and we'll trace out the function u x1 x2 as a utility mountain that assigns to each one of the bundles in the plane a height which represents the level of happiness we attain at that bundle. We can perhaps get an even better idea of what this utility function looks like by rotating it around and showing it to be a hollow mountain that has no peak. It has no peak because more is better, and so the more I stuff into your bundle, the higher a number the utility function will assign to that bundle. The height of our mountain is the level of happiness that's assigned by the utility function, and so if more is better, the mountain will never have a peak. If we now want to find all the bundles that give us utility level 2, we simply go to the height 2 and take a horizontal slice of this utility function. We can similarly ask what are all the bundles that give us utility level 4 or utility level 6 and take a similar horizontal slice of the function. The utility function we're using, by the way, is the function x1 to the 1/2, x2 to the 1/2, sometimes known as the Cobb-Douglas utility function, with weights 1/2 for each of the goods. If we now strip away the function and leave only the portions that intersected with the slices we've taken at utility levels 2, 4, and 6, we get a picture that looks like three indifference curves floating in the air. After a while, these indifference curves might get tired of floating around in the air, and so we can transfer them into the x1, x2 plane by first redrawing that plane and then bringing down each one of the three curves. We can furthermore indicate which of the curves attains what utility level by simply transferring the number of the utility level at which we took the horizontal slice in panel A of the graph. We can then straighten out our x1, x2 plane to get our usual graph of indifference curves. We can then think of indifference curves as slices of utility mountains, where those mountains can be represented mathematically as utility functions. The number next to an indifference curve then indicates the height at which that indifference curve happens on the mountain. Of course, that height depends on the ruler that we use to measure utility, and as we use different rulers to measure utility, that number is going to change. The shapes of the indifference curves themselves, however, should be unaffected by what ruler we use to measure happiness. If two bundles make me equally happy, it doesn't matter how I measure happiness, they'll still make me equally happy. We'll try to make this clearer next with two direct analogies to mountains, and then we'll return to the utility function and show how we can rescale the function itself, that is to say, change the ruler we use to measure utility, without changing the shapes of the indifference curves.